YC Mathematics and Physics, University Calculus, Lesson 7. Today we explain a test. We will give you the solution. This is test part 1. There are 6 problems, so I will only do 3 problems today. So this is part 1. Now, the number 1 question. Let's see here. Okay. Question 1. This is a question. You are required to find the limit of this rational function when y becomes very, very large. So y becomes very large. So part A. Let's see part A now. Is this answer correct? That is a question. Is the answer infinity over infinity? Now, obviously, how do you get infinity over infinity? Look at the question now. I better copy the question on my sheet. Okay. I have a rational expression minus 9y minus 4, and this is y squared plus 7y plus 9. Now the question is question 1a. Question 1a. Is this correct? Now you see y becomes infinity. So this y becomes infinity, infinity, and here you have infinity, infinity. Infinity is a number very, very large. So the top becomes a very large number, you write infinity. The bottom becomes also a very large number, so you write infinity. So is this the answer? No, this is not the answer. Because infinity is not a number. Infinity means whenever you say a number, infinity means more than that number. But it is not a definite number. It is a very large number, but it's not a definite number. Therefore, you don't have a definite number divided by another not a definite number, so you don't have a result. So this is wrong. Do not think this infinity and this infinity can be cancelled. Do not think that way. Don't think that way. Let me write it down now. Don't think this infinity and this infinity cancel, so you get 1, which is not true. Because infinity is not a number. So not a number divided by not a number, you cannot get 1. So question 1a, the answer is not correct. The reason is that infinity is not a definite number. Okay, question 1b now. Question 1b. 1b, the question is asking you, let us read the question. 1b, give 1 or 2 sentences Then you explain what you should do. Part A, we already said infinity over infinity is not the answer. Then what should you do? That's part B. Okay. What should you do? Remember the basic idea of doing a limit. The basic idea of doing a limit is construct a table of values. So this is what we can do. So we want to discuss what can we do with this problem. So we can do a table of values. Now I have done the table of values. I just give you the result. So this is y. And you want this function. So let's say this function, we don't have a function notation, but this is, okay, this is a rational expression, 7y squared minus 9y minus 4, and y squared plus 7y plus 9. Okay, so you give y numbers and work out this function. So suppose you have a y is equal to 0. Then you have negative 4 over 9, which is negative 0.4444. Now you give y a value 1. So you work it out, and I did, so the answer is negative 0.3529. Then you slowly increase the value of y, because the y must become a very large number, okay? It's very large, very large. So let's do 10. And I did it. Okay, use a calculator, all right? Use a calculator to do it. And I get the answer 6.4521. Now this is a number which is not too large, so let's make it large, 100. Then I did it again, use a calculator. I get let's see, 100. I get the it's 10, 1. Let's see, I maybe made a mistake. 10, okay, I made a mistake here. I just copied my answer wrong. I did it with my with a calculator. So this is, then if it's 100, it's 6.45 something. And then you increase the number again, becomes 1,000. And then I did it. Okay, I get the answer. Okay, this. All right, make it even bigger. And then I get okay, you just carry on. Make this number larger and larger. So you do that, larger and larger. What do you get? You see the answer is approaching 7. So make it larger and larger, you will have a number very close to 7. So it's very close to 7 now. So this is actually your answer. From the table values, you get the answer 7. So this is my answer. Question 1b is to ask you to discuss what way you can do to answer this problem, answer this limit problem. How do you answer this limit problem? What can you do? So one way is to do this. And I have another way. Another way is this. So you use qualitative argument. Use qualitative argument. Qualitative reasoning, okay? Argument. So how do we argue that? You want to make y very large. Y is very large. Then you will see that 7y squared becomes very large. Let's compare 7y squared with 9y. When y is very large, you will realize that a large number squared is larger than the number itself. So this will be larger than that when y is very large. So the argument is this. When y becomes very large, then I argue that 7y squared is larger than 9y. And of course it's larger than 4, right? So this is my numerator. My numerator is 7y squared is much, much larger than 9y and much larger than 4. Therefore, I can say the numerator is roughly 7y squared. Because you can throw away the 9y and 4. Again, when y is very large, then the denominator, y squared plus 7y plus 9, the denominator, in this denominator, this is much larger than that. And also the y squared is much larger than 9. So I can write y squared is much larger than 7y is much larger than 9. So my denominator can be approximately written as just y squared because this term is so big. Then what happens to the rational function? Then the rational function becomes, the original given function becomes 7y over y squared. So the numerator becomes 7y squared. The denominator becomes y squared. You throw away all the not so large terms. Okay, this is the largest term, so you keep the largest term. Then what this becomes, y squared and y squared cancels, so it is 7. The answer is 7. Here. Use qualitative argument, you get answer 7. This is easier, you see, instead of doing a table values. This is quicker and easier. All right. Now part C, question 1C. Question 1C. Question 1C says, then how can you do properly, carefully? So show all the steps. Can you do that? Mathematically, can you do that? Not argument, no argument, no argument. So how do you do that? All right. So let's copy the original given function. Okay, this is limit y goes to very large number, and I have 7y squared minus 9y minus 4, y squared plus 7y, and plus 9. So what do I do then? Okay, limit y becomes a very large number. What we do is divide the numerator by y squared, divide the denominator by y squared. You divide both the top and the bottom by y squared. So what do we have now? So I have 7 minus 9 over y minus 4 over y squared. And the bottom becomes 1 plus 7 over y plus 9 over y squared. So this is divide both the numerator and the denominator by y squared. Then you do the limit operation. Y becomes very large. Now when y becomes very large, this becomes 0. When y becomes very large, this becomes 0. When y becomes very large, 7 over y becomes 0. When y becomes very large, 9 over y squared becomes 0. Therefore, we do the limit now. This step is to do the limit. Seven minus 0, then 1 plus 0 plus 0. So what is this? 7. We got our answer here now, 7. So this is our answer for question number 1. Okay. Let's see question number 2. Okay, I must show you the original question. So question number 2. Yeah, here is a question number 2. Question number 2 is also do the limit. Evaluate the limit. The limit is x approaches p. X approaches p. P is a parameter, which means just a constant. A parameter is just a constant, but you don't know what constant is. Okay, so when x goes to p, what is the limit of the g function? Now remember that when x approaches p, you can approach p, but make it larger than p. In other words, you approach p from the right-hand side, or you approach p from the left-hand side. If you approach p from the right-hand side, your x value is almost p, but is larger than p. When you approach from the left-hand side, your x value is almost p, but is less than p. Now, look at the given function. If x is less than p, you must use the top function. When x is larger than p, you must use the bottom function. So let's do that now. I need to number 2. I need to copy this function. So let's do first x is less than p. Okay, let x is less than p. When x is less than p, I must use the top function. So gx is equal to the fraction 8x squared minus 8p squared and x minus p. This function is for x less than p. Okay. So you can factor out 8, right? Okay. And then you see you have x squared minus p squared. You can factor this out because this is a squared minus b squared. So this is equal to a plus b, a minus b. So you factor this. So you have x plus p, x minus p. And then you have x minus p at bottom. Look, the question is x approaches p. X approaches p means x is not equal to p. So this is not 0. This is not 0. Because they are both not 0, I can cancel it. So my answer is here. Now you do this. Limit x approaches p. This is x approaches p less than p. So it's on the negative side of p. So you go to this. So this is limit x approaches p negative. Oops. But this has no effect on here. X approaches p, but it's slightly less than p. Okay. So if you take the limit, you have 8 times 2p. So this is 16p. Okay, this is my result when x approaches p from the left-hand side. The next, I must consider x approaches p from the right-hand side. In other words, x approaches p, but slightly larger than p. Then I must use the other expression. So for x larger than p, my gx is 16x. Okay, I need to show you the question again to remind you that here, if x is less than p, I must use this expression. When x is larger than p, I must use this expression. Okay? So now I'm doing x larger than p, so I use this expression. So the limit x approaches p, but it's larger than p, so it's p plus. So x approaches p on the right-hand side. Then this is simple, right? You just replace the x by p. So this is equal to, when you do the limit, you replace the x by p, so you have 16p. So what we have now, we have limit g of x, x approaches p plus, p minus is equal to limit g of x, x approaches p plus. So these two limits are the same. Therefore, g of x, limit x approaches p without plus, without minus, then it is 16p, because they make no difference, plus minus. So this is my answer. This is my answer, and that is question number 2. Can you see it? Yes. So here, this is my answer. All right? All right. The next question, question number 3. So first, I need to show you the question. So here, question number 3, Q3. You have a graph which is called a g of x, and this is g of x. Okay, this curve is g of x. Here, g of x. Okay, g of x. So what is the question? Part A. Yeah, part A. What is the value of the limit when x approaches 8? Part B. What is the value of the function when x approaches 4? Oh, I'm sorry. It's not a function. It's 1 over g. Okay. What is the value of one of the given function? Given function is a curve. What is the value of the 1 over the given function when x approaches 8? And part B is when x approaches 4. Now, look, when x approaches 8, the function g becomes 0. But we need to approach this from right-hand side, and also consider the approach from the left-hand side. Look, when x approaches 8 from the right-hand side, the function itself, the g, is positive. It's almost 0, but it's positive. When it approaches from the left-hand side, it's almost 0, but it's negative. Therefore, for question 3, uh, 3a, so the limit x approaches 8, 1 over g of x. So what is this? So we need to consider x approaches 8 from the positive side, and also x approaches 8 from the negative side, from the left-hand side. Okay. So we need to consider these two cases, from right side and from left side. So we need the graph, okay? This is 8. The graph is like this. If it's 8 positive, the x value approaches from the right-hand side. So the g function is always positive, but it's very small. So when this is almost 0, but it's positive, what is this? It's infinity now. For this part, it approaches from the left-hand side. The g function is 0, almost 0, but it's negative. Therefore, it's infinity, but it's negative infinity. Since the limit of 1 over g, x goes to this, and the limit 1 over g, x goes to 8, negative, they are not equal. Therefore, limit x goes to 8 without positive and negative, just goes to 8. It's undefined, so does not exist. Okay, because this is not the same as that. Then part B, 3B. 3B, the only difference is that x approaches 4. So let's see, this is 4. What is the graph? So we consider x approaches 4, 1 over g. Let's consider 4 plus, and then let's consider approaches 4 minus. What is this? When x approaches 4 from the right-hand side, the g function is almost 0, but it's positive. Therefore, it is infinity. When x approaches 4 from the left-hand side, the g is almost 0, but it's positive again, so it's infinity. Since 1 over g, the limit x goes to 4 plus, and limit 1 over g, x goes to 4 minus, they are equal. Therefore, the limit x goes to 4 without plus, minus, just goes to 4, 1 over g, it should equal to infinity. Because they are both the same. So this is my answer. You follow? So I only do 3 questions, and I have 3 more questions. I will do it next time in my second part. If you have any questions, call this number. And my name is Fan. Yeah, call me and we will discuss the solutions here for question 1, 2, 3. Thank you for watching. See you next part. Bye.